Hello friends, I welcome you in lecture number 17 on partial ordering. In this lecture we are going to discuss one question on lattice which was asked in GTU Summer 2021 exam. The question is, let capital A be a set of factors of positive integer denoted by small m and relation is divisibility relation on that set A. For m equal to 45, show that the partially ordered set capital A with divisibility relation is a lattice. So here given set is the set of factors of positive integer m where m is 45. That means capital A is the set of divisors of 45 and divisors of 45 are 1, 3, 5, 9, 15 and 45, and here we have to consider all the possible divisors of 45 and we have to prove that this set capital A under divisibility relation becomes a lattice, and we are familiar with the definition of lattice now. We have to show that if we take any two elements from this set A, suppose we consider any two elements from this set A, then this subset must have least upper bound as well as greatest lower bound in the given set with respect to divides relation. Here given relation is divides relation or divisibility relation. So I have to decide that whether least upper bound and greatest lower bound exist for every possible subset having two elements. So you can see if I fix one and vary all these elements, then I have this type of pairs 1, 3, 1, 5, 1, 9, 1, 15, 1, 45, then 3, 5, 3, 9, 3, 15, 3, 45. So in that way I have to take subsets having two elements, all possible subsets having two elements, and I have to decide least upper bound and greatest lower bound. Because it is already given that this set is a lattice, we are just asked to prove this statement. You have to show that this is a lattice. So answer is already given, but we have to prove the answer. So we have to prove the existence of least upper bound and greatest lower bound for each possible pair of this type of elements. So suppose we check for this subset, then we can see first we have to check what are the upper bounds of this subset. Upper bound means those elements from set A which are divisible by 1 as well as 3. So one obvious element is 3 because 1 divides 3 as well as 3 divides 3. So 3 is an upper bound. Similarly 1 divides 9 and 3 also divides 9. So another upper bound is 9, and we can see 3 divides 15 also, and 1 also divides 15. 1 divides 15 and 3 divides 15. So 15 is another upper bound. Then 45 is also an upper bound because 1 divides 45 and 3 divides 45. So we have 4 upper bounds for this set having two elements 1 and 3. Now we have to decide whether least upper bound exists for this set of upper bounds or not. So least upper bound means we have to find out the upper bound which is related to every element of this set of upper bounds. So one obvious element is 3. It is clear that 3 divides 3, 3 divides 9, 3 divides 15 and 3 divides 45. Therefore 3 is the least upper bound. Least upper bound of the subset 1, 3 is nothing but 3 because 3 is the least upper bound, and we can see 3 is the least common multiple of 1 and 3 also. So in this way we can decide the least upper bound for any pair of elements. Now we check for greatest lower bound of this subset. So greatest lower bound means we have to decide that element which divides both of these two. So obvious element is 1 only, 1 divides 1 and 1 divides 3. Therefore 1 is lower bound of this set. And there is no other element which divides 1 as well as 3. Therefore greatest lower bound is 1. So for this subset, least upper bound is 3 and greatest lower bound is 1. And this is nothing but, you can see, this is greatest common divisor of 1 and 3. And here we can say that least common multiple of 1 and 3 is the least upper bound. Greatest common divisor of 1 and 3 is 1, which is the greatest lower bound of this set. So in this way we have to decide least upper bound and greatest lower bound for each possible pair of two elements. We consider another pair. Suppose I am interested in the set having two elements 9 and 15. So first I have to decide upper bounds of this set. So we know that 9 divides 45 and 15 divides 45. Therefore 45 is the only upper bound. 45 is upper bound of this set 9 and 15. So there is only one upper bound. This means least upper bound is 45. Now we check for lower bounds. So it is clear that 3 divides 9 and 3 divides 15. Therefore 3 is the lower bound. Similarly 1 divides 9 and 1 divides 15. So 1 is another lower bound. And we are interested in the greatest lower bound. So we have in the set of lower bounds we have 1 and 3, and we are interested in the greatest lower bound, and we know that 1 divides 3, therefore 1 is related to 3. Therefore greatest lower bound of 9 and 15 turns out to be 3, because 3 is the lower bound, and we have another lower bound 1, but 1 divides 3. Therefore 1 is related to 3, and therefore 3 is the greatest lower bound. Now here also you can see the pattern. This 45 is nothing but least common multiple of these two, 9 and 15, and this 3 is the greatest common divisor of 9 and 15. There are only two divisors, 1 and 3, and greatest common divisor is 3. So in this way this is true for all possible pairs. Therefore we can decide the least upper bound of any two elements by taking their least common multiple, and greatest lower bound of any two elements becomes greatest common divisor of A and B. So I have written all those possible pairs, and for each pair I have obtained least upper bound and greatest lower bounds. Least upper bound of 1 and 5 is 5, LCM of 1 and 5. Similarly for 1 and 9 it is 9, for 1 and 15 it is 15, for 1 and 45 it is 45. Then least upper bound of 3 and 5, it is least common multiple of 3 and 5, which is 15. LCM of 3 and 9 is 9, LCM of 3 and 15 is 15, and for 3 and 45 LCM is 45. I have written all possible pairs. LCM of 5 and 9 is 45, LCM of 5 and 15 is 15, LCM of 5 and 45 is 45. Similarly for 9 and 15 LCM is 45, for 9 and 45 LCM is 45, for 15 and 45 LCM is 45. Then we have to decide greatest lower bounds. So greatest lower bound is by greatest common divisor of two elements, GCD of 1 and 3 is 1 greatest common divisor. There is only one divisor here, which is 1. 1 divides 1 and 1 divides 3. So there is only one lower bound, 1. Therefore we have 1 as the greatest lower bound. Similarly, if I am having 1 as one element, then GLB is 1. If we consider greatest lower bound of 3 and 5, then it is nothing but greatest common divisor of 3 and 5, and it is 1 only. GCD of 3 and 9 is 3, therefore greatest lower bound is also 3. Similarly, here also greatest common divisor is 3, same thing here. Then if I consider 5 and 9, then the only common divisor is 1, therefore greatest lower bound of 5 and 9 is also 1. Greatest lower bound of 5 and 15 is greatest common divisor of 5 and 15, which is 5. And for 5 and 45, again we have 5. If we take 9 and 15, then greatest common divisor is 3. Another divisor is 1, but 1 is related to 3, therefore 3 is the greatest lower bound. GCD of 9 and 45 is 9, that is GLB is 9, because if we consider this set 9 and 45, then we can see 3 is also a lower bound, and 1 is also a lower bound, and 9 is also a lower bound. But 1 divides 9, 3 divides 9, and 9 also divides 9. Therefore, the greatest element of this set is 9, and therefore 9 is the greatest lower bound. Similarly, greatest lower bound of 15 and 45 is GCD of 15 and 45. Here also GCD of 9 and 45 is 9. So in this way you have to mention all the possible pairs, and you have to write that least upper bound and greatest lower bound exist for each possible pair. Therefore given set is a lattice. Here I have written, for any subset AB of A, there exists least upper bound and greatest lower bound of this set in A. Therefore capital A is a lattice under the divides relation. So this is all about this session, and this question was asked in GTU exam for 7 marks. And all we are using is the definition of upper bound, lower bound, greatest lower bound and least upper bound. So this is all about this session. I hope you like it. Thanks for watching.